Hi, my name is Hamza Arshid, and today we will do the topic complex numbers under SAT Mathematics. Alright, so first off, when we talk about complex numbers, we talk about this special number that is called I or iota. And I is basically equal to the root of -1. So this is also known as an imaginary number, and in this chapter, this is basically the main number that we will be using, and this is the imaginary number, and it is root of -1. So here we have a few examples. For example, we have root of -25. Another way to write that would be root of -1 times 25. So we can separate that into two parts, root of -1 and root of 25. Root of -1 is simply I, and root of 25 is 5. So we can write this as 5i. So in the second one, we have -12. So let's just do something similar for this. -1 times 12. So -1 and then 12. Alright. So and so what we're gonna also do next is to simplify this further, times 4 into 3. So the root of 4 is 2, but we do not have any perfect root of 3. So we're just going to write this is I, this is 2, and root 3. So 2i root 3 is your answer here. Alright, so first off, let's talk about addition and multiplication using complex numbers. So when it comes to addition, this is pretty straightforward. When you're adding, you will add the real numbers together and you will add the imaginary numbers together. So when you have 3 plus 2i plus 4 plus 3i, so you will write that as 3 plus 4, which is 7, and 2i plus 3i, which is 5i. So 7 plus 5i. Similar for subtraction, you will subtract real numbers from each other and you will subtract imaginary numbers from each other. So 10 minus 2 is 8, and 5i minus 3i is 2i. So that's it for addition and subtraction. Alright, so let's talk about multiplication. So now we have 3 plus 2i multiplied by 4 plus 3i. So we're just going to multiply these two brackets the same way we multiply any two brackets. First of all, 3 times 4 plus 3 times 3i plus 2i times 4 plus 2i times 3i. So we have 12 plus 9i plus 8i plus 3 2s are 6, 6i square. So 12 plus 17i plus 6i square. So since I is equals to root of -1, we can also say that I square is equals to -1. So 12 plus 6 minus 1 plus 17i. So you will get 6 plus 17i as your final answer. So whenever you see I square, just write -1 in place of that, because I square is equals to -1. Alright, next up we have magnitude of absolute value. So normally when you are asked to find out, for example, the magnitude of x plus y, then you put this into the modulus x plus y. The magnitude of x plus y is equals to root of x square plus y square. So when you have within the modulus an imaginary number, the question is, what are you going to do when you have that? The answer is that you do not do anything about the I. For example, if you have to find out the magnitude of a plus ib, or the modulus of a plus ib, so you will simply write a root of a square plus b square. You will not write I when you're writing this formula, right? Under root of a square plus b square. So we won't really consider the I. Forget about the I, there is no use here, as written in the bracket. So down here we have another example. The magnitude or the modulus of 3 minus 2i is equals to root of 3 square plus minus 2 square, and that gives you root of 13. So we will simply not do anything about the I when we have to find out the magnitude of something that has a complex number inside it or an imaginary number inside it, which is I or root of minus 1. Another thing that the SAT usually tests is that they give you basically this expression in which I is in denominator, and they basically ask you to simplify that expression. So for that you will use this rule. I should never be in the denominator. Whenever you see I in the denominator, your first instinct should be to remove that I. So how do we remove that I? That's probably the question that's in your mind right now. So to remove I from the denominator, we take conjugate. So so here you have um, 7 minus 4i over 1 minus 2i, and we have to remove the I from the denominator. So what we're going to do is we're going to take the conjugate, and here um, this is your conjugate. So the conjugate is basically an expression or a number which is taken when you look at the denominator. For example, if the denominator is 1 minus 2i, the conjugate of that will be this 1 plus 2i over 1 plus 2i. So, for example, if you have in the denominator 4 plus 3i, so the conjugate of that will be 4 minus 3i. It's basically changing the sign that is in the middle of the expression. So you will multiply this by 4 minus 3i over 4 minus 3i. That that expression that you have come up with by looking at the denominator, it should be both in the numerator and the denominator, and you basically multiply this fraction with the original expression. And this is basically how you take conjugate. We will do more examples of this in our practice questions video. So let's look at this. Let's go at it from the start again. 7 minus 4i over 1 minus 2i. To remove 1 minus 2i, we will take conjugate. And the conjugate of 1 minus 2i is 1 plus 2i, because we're changing the sign in the middle. And you will multiply this with 1 plus 2i over 1 plus 2i. And why are we dividing 1 plus 2i with 1 plus 2i? We're simply doing this because essentially when these two cancel out, this will just give you 1. So the original expression is not changing. So whenever you're taking a conjugate, it will be both in the numerator and the denominator, so that the original number is not changed. You are just manipulating with the original number. So 7 minus 4i, we've multiplied this by 1 plus 2i, and we've multiplied the denominator with 1 plus 2i as well. So we get 7 plus 14i minus 4i minus 8i square. And in the denominator, we have 1 minus 4i square. So wherever you see I square, you will write minus 1. So 7 plus 8 multiplied by minus 1 plus 10i over 1 minus 4 multiplied by minus 1. And you basically solve that, and in the end you get 3 plus 2i. So do note that these two are basically the same thing. And why are these the same thing? Because we are simply multiplying it by 1 essentially, because you cancel both of these out and you just get 1. So this is a way to change the expression in a way that the denominator does no longer have a complex number or an imaginary number. So this is what we do to remove the an imaginary number from the denominator. All right, so here we have a question. Find the magnitude of 5 minus 3i over 1 minus I slash distance from origin. So there's basically two ways they can ask you this. Either you find the magnitude of something, or you find the distance from origin of something. But in both cases, you will use the modulus formula, which is basically that the modulus of x plus y is equals to root of x square plus y square. So here we have to find out the magnitude of 5 minus ci over 1 minus I. So First things first, if we have I in the denominator, we're going to remove I from the denominator. So again, take conjugate. In the denominator, we have 1 minus I. So the conjugate of that is 1 plus I. So 1 plus I over 1 plus I, and you're multiplying this with the original equation, or the original expression, sorry. You multiply this and you get 4 plus I. Just to repeat, 4 plus I and these are the same thing. 5 minus ti over 1 minus I and 4 plus I, these are the same thing. However, when you're writing this as 4 plus I, there is no I in the denominator, which is what we're trying to go for. So now it's pretty simple. We just have to find out the magnitude of 4 plus I. So 4 plus I magnitude is root of 4 square plus 1 square, because I is basically 1I and we won't actually take I when we're putting this into the formula. So we get the answer as root of 17. Alright, so here we have another concept that the SAT usually tests when it comes to complex numbers. So we already know that I is minus 1, root of minus 1, right? So I square is minus 1. So I cube, what will be I cube? I cube will be minus 1 into I, or minus 1 into root of minus 1. And that will simply give you minus I. Whereas when we talk about I to the power 4, then that is minus I times I. And that is, as I've written here in yellow, minus I times I is equals to minus I square. I square is I square is minus 1. So when we do minus minus 1, that will give us 1. So I to the power 4 is 1. So here's one thing that they can do to you, right? In one of the questions, they can ask you that find I to the power 36. So a very simple way of going about such questions is to simply divide this power by 4. For example, we're dividing 36 by 4 and we get 9 and the remainder is 0. So the power is a multiple of 4. And by virtue of that, we can say that I to the power 36 is 1. And to summarize this, I have written here, if the remainder is 0 and remainder upon dividing it by 4, dividing the power by 4, if the remainder is 0, then it's 1. If the remainder is 1, then it's I. If the remainder is 2, then it's minus 1. And if the remainder is 3, then it's minus I. We will also practice this in the practice questions video for complex numbers. But just to go over this again, I is root of minus 1, I square is minus 1, I cube is minus I to the power 4 is 1. Whereas when there's any random number given to us, any random power given to us, I to the power 46, I to the power 47, anything, you're going to divide it by 4, you're going to see the remainder, and then you're going to compare this against what I've written here. Either the remainder is 0, it's a multiple of 4, then you simply have it as 1. If the remainder is 1, then it's I. If the remainder is 2, then it's minus 1. If the remainder is 3, it's minus I. So here's just a summary of what we have done in this video. First of all, we talked about iota. We said that I is equal to the root of minus 1. Then we talked about addition, where we're just adding the real numbers and adding the complex numbers. And then we talked about the modulus, or the magnitude of something that includes the complex number, where we don't really do anything with the complex number. And then we talked about, to remove I from the denominator, we take conjugate. So the conjugate of 4 minus I is 4 plus I. You just change the sign in the middle. And minus 6 plus I is minus 6 minus I. So there's that. I to the power of x, to find out what I to the power x is, you divide x by 4 and you check for the remainder. If it's 0, then the answer is 1. If it's 1, then the answer is I. If it's 2, then the answer is minus 1. And if it's 3, the answer is minus I. That is it for complex numbers.